This example, the class student, demonstrates some of the features that we have discussed above. And so, for instance, here we have a constructor, and as usual, that's called init. The constructor this time takes two parameters in addition to self, and these are the name and surname of the student, and they are assigned to the attributes self.name and self.surname. Notice one thing here, that I could have called these two N and S, but I call them name and surname just as the attribute itself. This does not really cause any confusion to the interpreter. So self.name is an attribute of the object and it persists after the constructor exits, while name is a parameter of the constructor. They are two different things. So it's actually common practice to name them in the same way so that you don't have to worry which is which, but at the same time, this leads to no confusion from the code, the interpreter point of view. Also, as you see here, the constructor initializes another attribute, print account, and that is not passed as a parameter, it's always initialized to 0. Print account is then used by the other two methods, by print credit and canPrint. Now, the one thing that's slightly different in this example is that we introduced this variable called university, and this variable is not prepended by self. There's no self in front of it. It's not inside the method, but it's inside the class. That's something we haven't seen before. So what is that? That variable is a so-called class variable. Class variable meaning that is common to all the objects of that class. And this is a very important difference that distinguishes it from attributes. Concretely here, when we create two students, Monty Python and Mary Poppins, and we assign them to variables A and B, we can print the name of student A, and that's Monty, and we can print the name of student B, and that's Mary. Now, each student has his or her own name. Well, it wouldn't make any sense to have something like print student.name, because there is no name common to the entire class. So you can't a priori, without knowing what student you're talking about, you don't know their name. And the compiler tells you, okay, the type object student has no attribute name. But actually things change for the university variable. So you can print student.university because that's the same for all students. And if you do change that variable, that's changed for all students. Again, that's not the case of the name. If you change the name of a student, that doesn't change the name of the other student. So if you change Mary's name to Jane, that only affects Mary, so only affects student B. So I've skimmed really quickly over these lines of code here, but they are in the notebook, and so you can try them slowly and figure out how they work. The core message is that class variable is shared between all the objects of the class, while attributes are pertinent to each individual instance, so each individual object. And in general, that's the behavior you want. So you want to create objects that are instances of the class, that each have their own name, their own surname, their own print account. Very rarely you're in the situation where you need a shared variable, but if you do have that need, then Python allows you to do that. So this example also demonstrates one of the three features that we said are characteristic of object-oriented programming approaches, and that is encapsulation. As we see, all the data for the student, their name, their surname, their print account, their university too, they are all wrapped inside this class, and they all pertain to the particular object. So when you ask yourself whether the student can print, for instance, the function, the method can print does not need to look outside the object to give you a reply. They can just act on the attribute of the object, the attribute print account. So this meets a broad definition of encapsulation. If you want, more specifically in some languages, by encapsulation, you indicate the fact that actually objects are structured in such a way that access to some attributes is not allowed. This is really not possible in Python. So in Python, one can always access all the attributes from the outside, and by accessing them from the outside, I mean something like that. You can print a.name, and that gives you the name of the student. So you can read this name, a function such as print, that can access this name by just writing the name of the variable .name without that function being part of the class itself. While in some languages you have a way to restrict access to some attributes to the functions that are physically inside the class, so to the methods of the class. As said, this is not possible in Python. Now, why would you want to do that? You would want to do that because sometimes you want to hide details of the implementation from the person who uses the class. Not so much for security purposes, but because, for instance, you might want to change these later and you don't want the final user to either rely on a particular representation or to tamper with it. But there is a convention in Python whereby if you put an underscore in front of the name of an attribute, that attribute is meant to be private and you're not supposed to touch it from the outside. This does not really prevent me from doing it. So I could do, for instance, here, besides doing a.can_print, I could just try to print the print account value directly. And I could even assign to that, but so Python does not prevent me from doing it, but the convention is if you see that an attribute has an underscore at the beginning of its name, that means you are not supposed to meddle with that, so leave it alone.